The aim of the first three activities is to reacquaint us with why equations define lines. If I grab that point A, and apparently this line's called x equals 3, and drag it down, I drag it little steps and let go each time, you'll see its coordinates get recorded in the spreadsheet on the right here, and you might see why that's called x equals 3. Do the same with B, drag it, its coordinates get recorded. You can use the scroll bars to see that more clearly and remind yourself why. You can then drag those horizontal and vertical lines and try again and understand why the next set and how those equations define each line. Then we move on to diagonal lines, same idea. Apparently this one's called y equals x minus 2. Drag the point B and see why that's called x equals minus 2. You can do the same with the point A. It might be hard to see the relationship between the x and the y coordinate, sometimes it might not. The circle and triangle toolbar, if you click on it, it shows you all the properties for the object that you're currently working on. Click on the line, it shows you the line properties. Click on the graph, it shows you the graph properties. On the graph, I've got point capture, fixed to grid, and now it will only do 0.5 values of x and y, which make it a bit easier to see maybe what the relationship between those is.
You can then select the data, Control C, don't use right click and copy because it doesn't tend to work so well in pasting Word. Four-headed arrow at the top left there, click on it and then it pastes it all in really nicely, and you can analyse that data in the Word document.
So point capture is quite helpful to clarifying the relationship. So you think I understood each of these points is imprisoned by a mathematical formula. You have to find that mathematical formula. Why can't I drag that C except in certain places? So right click on the points, trace to spreadsheet, and again now you should be able to work out what the equations of each of those lines are, same for A and C. When you think you've got all that, you're ready to enter in the equations yourself because you're a master of line equations. So I might put in here, be careful, only use lowercase x 0.5 in the input bar at the bottom there. I just want to change the properties of that line, so when I click on it, the properties circle and triangle toolbar, I can make that red, I can make it dashed, and I can increase its thickness a bit. Great. 9's quite a nice thickness, or 8. Going to reflect it. I get a nice reminder at the bottom about what I have to do to reflect that. Select the object, great, so I will. Select the line, and that reflects it. Not quite right, so what I'm going to do is I'm going to click on the arrow to undo the fact that I want to reflect because I don't anymore, and then I want to select my line. And when I've got the line selected, I can select its properties, object properties there, and I get a bit more detail than just the circle and triangle, and I can actually change its equation and see if I can try and get that a bit closer. I'm getting a bit closer, over to you to do the rest. Same thing on this second one, which is a bit tougher, but the line's already there, so you only have to right click and straight away change its equation until you can answer those 4 questions. When you've finished all of that, it's time to let your creativity loose, and I advise only 1 or 2 shapes max because it's really the transformations that make it beautiful. And take a screenshot and compare with the rest of the class. There's another extension challenge there and on the activity page when you animate your beautiful creation so that it becomes a video. Help videos for GeoGebra and Autograph are here, and some resources if you want to do all of this in Autograph. Just click on that arrow and you can see. Happy exploring, over to you.